ladies and gentlemen. Today we will discuss about mass wasting and Earth's internal heat. But before that, let us first discuss what exogenic processes are. Exogenic processes. The Earth's surface is composed of water and land masses. The solid portion is made out of rocks and minerals that could experience changes either physically or chemically. The weathered materials are transported by different agents from one place to another and will settle down in a particular area. These progressions that happen are achieved by forms called exogenic processes. It includes weathering, erosion, and deposition. Under erosion, mass wasting is the movement of rock and soil downslope under the influence of gravity. Rock falls, slumps, and debris flows are all examples of mass wasting, often lubricated by rainfall or agitated by seismic activity. These events may occur very rapidly and move as a flow. Landslide triggers may include the following: intense rainfall, rapid snowmelt, earthquake, volcanic eruptions, stream or coastal erosion. The runout of a mass wasting event depends on the volume of material, water content, and slope steepness. Now, let us proceed to the Earth's internal heat. But before we go to that, let's have a short review of layers of the Earth. Basically, planet Earth has three main layers. These are crust, mantle, and core. The crust of the Earth is a very thin layer when compared to the three other layers. The mantle is the largest layer of the Earth, being estimated 1,800 miles thick. The outer core is composed of liquefied metals such as nickel and iron. It is kept in a liquefied state because of the immense heat within this layer. The inner core is also composed of metals. However, they are not kept in a liquefied state. It is believed that the temperature and pressure at depth is so great that the metals are squeezed tightly together, restricting movement so much that the particles have to vibrate in place almost like a solid structure. Following that, we have two types of heat, which are the primordial heat and radiogenic heat. During the early formation of the Earth, the internal heat energy that gradually gathered together by means of dispersion is the planet during its few million years of evolution is called primordial heat. The major contribution of this internal heat is the accretional energy, the energy deposited during the early formation of a planet. The heat of the core takes tens of thousands of years to reach the surface of the Earth. As for the radiogenic heat, it is the thermal energy released as a result of spontaneous nuclear disintegration. It involves the disintegration of natural radioactive elements inside the Earth, such as uranium, thorium, and potassium. Uranium is a special kind of element because when it decays, heat is produced, which we call radiogenic. Both sources of heat, whether primordial or radiogenic, undergo heat transfer, and it plays an important role to the continuous changes and development of our planet. And these are the three processes: conduction, convention, and radiation. First, we have conduction. It is a process by which kinetic energy is transmitted through collisions between neighboring atoms or molecules. And here we have a medium so that we can transfer heat. Next is convection. It occurs when hot air rises, allowing cool air to come in and be heated. And convection is also a more efficient means of heat transport in the Earth compared to pure conduction. And the third one is radiation. It occurs via electromagnetic waves. Unlike conduction and convection, this occurs without any medium and is in the form of magnetic waves.